All right, let's take some really quick notes on 5.1. I apologize if the sound isn't as good as normal. I don't have my microphone, so just bear with me. But go ahead and take these notes at your own pace. I'm going to try and go as quick as I can. So if you need to pause and write something, just pause real quick and get it all written down. But a lot of this stuff we've already talked about. We've got the pieces built out already. Now it's just putting them all together. So, of course, let's start slope-intercept form just to recap. Y is equal to mx plus b, right? As we know, Yo Mama's ex-boyfriend, where m is the slope, b is the y-intercept. So in slope-intercept form, we're going to plug in the slope, and we're going to plug in the intercept, and we're going to have our equation. So the first way that we're going to do that is from 2 points. So from 2 points on the line. Okay, from 2 points on the line. So let's say I've got a point 2, 3, and I've got -6, 7. So those are 2 points on some line. We don't know what the line looks like. We don't know where it crosses the y-axis. So we're going to have to figure that out, okay? So the first thing we want to do is find the slope. We're going to use the slope formula. M is equal to y2 minus y1 over x2 minus x1. I'm going to label my points x1, y1, x2, y2. And then I'm going to plug them in. y2 minus y1 is 7 minus 3. x2 minus x1 is -6 minus 2. Well, 7 minus 3 is 4. -6 minus 2 is -8. And 4 over 8 simplifies to -1/2. Okay, so there's my slope. I've got my first part done. So now that I have the slope, I'm going to use that slope and one of my points to be able to find my b. So let's say this is step 1, is finding the slope. Okay, step 2 is going to be finding the b. Now, luckily, we already have notes on how to do that. We look back to, where was it? 4.3b, solving for b. It's exactly what we've been doing. We started with the slope, so this time we have to take the extra step of finding the slope. And then we just plug in our 3 puzzle pieces in order to find out what b is. So here's my m. I'm just going to take this first point right here because I always like working with positives. Negatives scare me, so I'm just going to use positives. So I know my m is -1/2. All right, let's get that out of the way. M is -1/2. For my first point, x is equal to 2, y is equal to 3. So I'm going to take my slope-intercept form. Y is equal to mx plus b. I'm going to plug in 3 for y. I'm going to plug in -1/2 for m. I'm going to plug in 2 for x. And now I'm just going to solve for b. So I've got 3 variables that I've filled in with some numbers. B is all that's left. So let's go ahead and solve for that. Obviously, we're going to multiply first. -1/2 of 2 is -1. And then if I want to get b all by itself, I got to do the opposite of -1, which is +1 on both sides. That'll cancel my 1's over there and leave me with b is equal to 4. So there's my y-intercept now. So I found my m using the slope formula. I found my b using the slope and a point in the slope-intercept form. Now that I have my m, now that I have my b, I'm going to write the equation. So this is the final step here, step 3. Just write the equation. Y equals mx plus b is going to turn into y equals, we plug in the slope, -1/2. X stays as x, plus my y-intercept of 4. There's my equation in slope-intercept form. So we're not always going to have a negative slope. Sometimes it'll be positive. We're not always going to have a fractional slope. Sometimes it'll be a whole number or an integer. So whatever you got, just plug it in, make sure everything works. You could also, if you want to, you could take your second point and plug it in here and see if you get a true statement. So if I wanted to, you don't have to do this, but like on the quiz we took yesterday, right, it might be nice to be able to check our work sometimes. So if I take this second point, the point I didn't use, and I plug it in here, x and y, I would have 7 equals negative 1/2 of negative 6 plus 4. Well, half of 6 is 3. A negative times a negative is a positive, so that gives me 3. So 7 equals 3 plus 4. And 3 plus 4 gives me 7. Well, 7 is equal to 7. So I've confirmed that, yes, this equation is right. And both of these points are on this line. So we could always just plug in the x and the y to figure out if a point is on the line. Can't remember if the book assignment has those problems included in it, but if it does, you're just plugging it in and seeing if it works out. If you get a true statement, it is on the line. If you get something like 5 equals 7, which is obviously not a true statement, then it would not be on the line, right? So that's our first way. I'm going to pause there for a second. I'm just going to double check the bookwork real quick. Is it B11? Yeah, B11. Okay, so yeah, from a point and a slope, that's 1 through 6. That's easy. Okay, the word problems from 2 points, word problems, and the graphs. Okay. Okay, so real quick, we're not going to take a look. We're not going to take notes here on graphs, but we are going to go back a little bit. I'm almost positive we did this already. Okay, so when we did 4.1a, graphing linear functions, what we did was we started with the equation. We figured out what the b was. We figured out what the m was. We made our beginning dot at the b, and then we rose and ran based on the slope that we have. So now imagine I don't have any of this information. All I have is this line. How can I write the equation? Well, b is wherever this line crosses my highlighted y-axis, which is 2. So I know that b is 2. And then I'll just pick another point on that line like this one. I'm going to start from my b, and I'm going to count my rise, 1, 2, 3. I'm going to count my run, 1, 2, 3, 4. Well, if my rise is 3, my run is 4 from one point to the next, then my slope is going to be 3 over 4. So it's just reading the graph, reading the line on the coordinate plane. There's my b, there's my m. I can write the equation y is equal to mx plus b. It's exactly what we started with, right? So for the graphs on B11, they are a little bit tricky because I don't think it gives you like definitive points. I don't think it shows you like, hey, here's a big old dot where there's a point. Kind of have to find for, oh, it does. It does, yeah. So just be careful. Some of them also, they give you a slope and a point. You could just do it that way by plugging everything in like we just talked about in this section. Everything we just wrote, right? Starting at step 2 with a slope and a point. Slope and a point. Some of them gives you 2 points. So you start from step 1. You can do it that way too because the y-intercepts aren't totally identifiable on some of them. Some of them it looks, if it's in between 2 and 4, like on number 31, you could assume it's 3, but we never want to assume anything in math. We always want to make sure that we're finding the exact answer. So that was from a graph, right? Referring back to that. Now we're going to talk about from a word problem. So hopefully you're able to get one of these little papers from the guest teacher. Okay, if not, just go ask them for it. I'm sure they'll give it to you. I mean, it's right there on my desk, so there's plenty for everyone. And this word problem says Nebi has already typed 250 words. He then starts a timer and finds that he types 150 words in 3 minutes. If Nebi types at a constant rate, it's a key word there, constant rate. Write a linear equation to represent the number of words W. Number of words W. Nebi types in M minutes. So for this, we're not going to use X and Y. We're going to use W and M, where W is the number of words. I'm going to just write this out. W is the number of words, and M is the number of minutes. Now, something that we haven't really talked about before is independent and dependent variables. When I have a function in slope-intercept form, my x and my y represent an independent variable and a dependent variable, okay? Now, it's kind of tricky sometimes when we're given a problem like this to figure out which one is independent and which one is dependent. So let's go ahead and write independent variable is always going to be your x, which is your input. Your dependent variable is going to be y, which is your output. And the way that I always remember this, I mean, we've talked about Yo Mama's ex-boyfriend. We've talked about why aren't you over your ex. If you're independent, you don't need your ex anymore, right? It's probably the easiest way to remember it. Independent, think X. If, oh, you were together and now you got an X, hey, I'm independent now because my ex and I aren't together. So independent X, obviously that means that dependent is going to be Y. So what that means is that whatever my variable represents for Y, that quantity depends on whatever number I have for X. So if we look at this context, right? The number of words you type and the number of minutes. Well, which of those things depends on the other? Well, the number of words that Nebi types depends on how many minutes they've spent typing. If they spent 1 minute typing, they've probably typed less words than if they spend 2 minutes or 3 minutes or 4 minutes typing. So just logically working through this, thinking through this, the number of words they type depends on the number of minutes. So the number of words is my dependent variable, and the number of minutes is my independent variable. The number of words I type depends on the number of minutes I've spent typing. So minutes is my X, words is my Y, okay? And one way that we could tackle a word problem like this is to make a table, okay? Normally we'd have X and Y, but here my X is actually M, number of minutes, and Y is actually W, number of words. Okay, because finding slope and y-intercept from a table is super, super easy. We just got to fill in some information. So Nebi has already typed 250 words. Right away, I read that. I know 250 is my beginning amount, right? The number of words is y. So if Nebi has already typed 250 words, that means he's typed 250 words after 0 minutes. That's my starting amount. I know right away. Speed blue, yeah, that this right here is my y-intercept. Okay, again, we're still writing equations, so we want to know the m and the b. Right away, I could find the b just like that. He already typed 250 words. Then he starts a timer and finds he types 150 words in 3 minutes. So here's where we might make a mistake. You might go, oh, 3 minutes, 150 words. But that's not what we're going to do. We're going to add 150 words to the amount we already had. So what's 250 plus 150? That would be 400. And how much time did it take him to type those 150 words? Well, 3 minutes. So we're going from 0 minutes to 3 minutes, and that gives me 3. Okay, now I essentially have 2 points on this line, 0, 250, 3, 400. I could find my slope or my unit rate by dividing the change in y, or in this case the change in w, divided by the change in m, or typically it's the change in x, right? Because, what color is it? Purple? M is equal to the change in y over the change in x. Here the change in y was 150. The change in x was 3. Well, what's 150 divided by 3? That would just be 50. All right. Now let's say we didn't make a table. Let's say I just took this 150 words in 3 minutes. Now that's not a unit rate, because a unit rate, my second quantity has to be 1. Here it's 3, but it is a rate. So we could have just ignored all this, right? Maybe the dependent independent stuff doesn't make sense. Well, you can figure out the slope by using that rate, 150 words in 3 minutes, right? Words is y, minutes is x. 150 divided by 3 gives me 50. So now I have m, right? I also know that they've already typed 250 words. Okay, so that means I have the point 0, 250. Well, if I take y equals mx plus b, plug in 250 for y, 50 for m, 0 for x, and then solve for b, well, 50 times 0 is 0. I don't really need that. And I see that b is equal to 250. So just like we were able to find on the table, right? And yes, you may have noticed, oh, that point already has a 0 on the x, so my y coordinate must be b. Yeah, exactly right. Okay. So it's really important we're able to read this problem or a problem of this type and be able to explicate or understand what the information that we're given actually represents in terms of what we need it to represent for this problem. Anyway, we know the m, we know the b. We can write the equation. Y is equal to mx plus b turns into y is equal to 50x plus 250. And now what this function represents, it tells us right away that y, actually, you know what? I totally messed up because we're not using x and y. We're using m and w. So instead of y, we're going to write w equals 50m plus 250. I apologize. I was getting ahead of myself there. So this tells me that the number of words that Nebi types is equal to 50 words times the number of minutes he spent typing, plus the 250 that he already had logged before he started his timer. So he's going 50 words per minute, 50 words per minute, plus the 250 that he already had typed, right? And we can assume, based on this constant rate, he was probably already typing for, 5 minutes before he started the timer? 50, 100, 150, 200, 250. Yeah, he was probably already typing for 5 minutes if he was going at that constant rate before the timer actually started. So obviously not every word problem is going to be exactly like this. Some of them are a little bit different, but I want you to make sure that you're able to use what we know about this process and kind of how this function works so that we can figure out how to write an equation for it based on the information that we're given, whether that's making a table, just using some logic, going back to the process from the previous page, right? 2 points, or just from step 2, a slope and a point, right? Hopefully we're able to figure out those word problems because those are typically the more tricky ones, but they're also the most important ones, especially in terms of state testing and all that good stuff.